Hi there. I'm Dawn Wright, Chief Scientist of Esri, and my colleague.
Christian Harder, also with Esri, specifically content strategist and writer and editor for Esri Press.
And we're so very pleased to be invited to the American Geographical Society's book talk. And we are here to talk about our latest book that we co-edited together. It's called GIS For Science, Applying Mapping and Spatial Analytics. And we're going to use the time today to go through this book with you, to give you some background on how the book came to be, to talk about the various stories that are in the book, the design elements, and also the supplementals that go with the book. So I'm going to start off just by giving a very brief introduction to how this book came to be. And I'm going to pass off to my colleague Christian at that point, and we're going to go through various chapters in the book that are very specific to oceans, especially given the Geography 2050 ocean theme of your conference this year. So first of all, GIS for Science is a book that we think is very timely. It was commissioned by our CEO, Jack Dangermond, because he really wanted to have a book that showcased how scientists are using the power of geographic information systems to solve real-world problems. And so the power of this book is that it is actually written by scientists. And there are all kinds of wonderful examples of our human impulse to solve problems, to discover things about the earth, things about how we are using the earth, ways in which we are observing the earth. In fact, the book is separated into these different sections that focus on those activities, and also how geography and GIS can provide an objective platform for effectively conducting and sharing scientific research. So the goal of this book is to spotlight the amazing work of scientists around the world in various scientific disciplines. In fact, this book, GIS for Science, with this orange cover, is the sequel to the first book that came out last year, GIS for Science, Volume 1. Now, in the pages of these books, you will learn about sustainable precision agriculture, geological processes beneath the earth, disaster response, ecology, all kinds of topics. But we wanted to first start off by telling you a bit about the cover, because this second volume of GIS for Science has some very powerful ocean content. And what you're looking at here on the cover is a very different way to view the ocean. This is actually a map that was based on the work of Athelstan Spielhaus. If you're familiar with Spielhaus, you know that he was a very distinguished meteorologist, but he was also an oceanographer, an inventor. He designed the very first bathythermograph. He designed a weather balloon that was actually mistaken for a UFO over Roswell, New Mexico. He was actually involved also in designing some of the skyways of Minneapolis, Minnesota. But one of the things that he did in 1979 was to conceive of this map that you're seeing here that shows all of the oceans as one interconnected ocean. And this is often referred to as the Spielhaus map of 1979. It was very popular at that time, and it has come back into vogue, especially now as we're talking so much about how we need to conserve and better manage the ocean as one body, and as we go into the UN decade of ocean science for sustainable development. Now, the challenge with Spielhaus's work is that he never did the mathematics to actually make this into a projected coordinate system so that it could be used in modern computerized mapping systems like GIS. Well, interestingly enough, JCOM came to us at Esri. JCOM is the Joint Technical Commission for Oceanography and Marine Meteorology. It's a group that leverages the World Meteorological Organization as well as UNESCO. They came to us and said, "Can you?" And they're a heavy user of our ArcGIS software, and they said, "Can you please help us to be able to use Spielhaus, this map in GIS, specifically in ArcGIS?" So our projection geometry team did the mathematics necessary in order to make the equivalent of a Spielhaus projected coordinate system. It's actually based on the Adams square 2 map projection. And in this way, this is now in ArcGIS software. You can recreate this map as a base map. You can put other layers on top of it. So this is where our cover derives from, because you're looking at the Spielhaus map. Overlaying on top of it is the world ocean floor geomorphology. And later on in the book, you can actually see more about how this projected geometry system came to be in the technical showcase section of the book, which talks about some of the innovations that Esri staff specifically have made toward GIS. But now to pass over to my colleague Christian, one of the things that's really powerful about this book is the way that the stories are told. And Christian, would you like to talk about the layout of the book in terms of how you, as the designer, approach this? And maybe we could go to the first ocean-based chapter, or how would you like to start off?
Yeah, we can go to the first ocean chapter. I think that's the USGS work, Roger Sayre's work.
Mm-hmm.
Um, One of the kind of guiding principles of this work was that we wanted to make the work of these scientists accessible to a broader audience. In other words, we didn't want to just write another research monograph for other scientists. We were trying to make a book that would appeal to a much broader audience of GIS professionals, people in the Esri ecosystem, and also just a general audience of people in the world that are interested in science and the world around them. So we came up with a large format, kind of almost a coffee table format. And the idea was that we would fill the pages with rich graphics, well-edited text, not a lot of text, more kind of graphically oriented. Don, you can just maybe start paging through here. This particular chapter, I'm kind of jumping ahead here into the content a little bit, but this is the work of Roger Sayre and the USGS and Esri around the kind of cataloging of all the islands in the world. So what was the actual number? 380 something thousand islands. Don, was that?
Yeah.
So
Yeah, and this was actually part of our project to create a global ecological coastal ecological units system.
right. So up until recently, believe it or not all of the islands of the world had ever been captured into a geographic database. So this chapter gets into a little bit of the history of islands as they've been mapped through history. Keep paging through, Don. And okay, starting in here, we start getting into the first efforts to actually digitize and capture the world's islands. And so you can see here the kind of progressive improvements in accuracy that have been made over the years. And if you page one more page, so this is kind of where we are now in terms of spatial accuracy. If you can imagine the work of digitizing 380,000 islands greater than 1/2 kilometer in area, I believe was the threshold. It's a huge amount of work, and it wasn't done fully automatically or fully manually. It was kind of a semi-automated process using satellite imagery and other remote sensing data sources to compile this data. So this chapter is really a little bit about GIS, but also a little bit about the kind of history of the geographic study of islands, and then it also kind of segues into some of the applications of this data. And now maybe Dawn, you could talk briefly about how the data is actually applied out in the world.
Yes, because one of the nice things about this project is that it's a continuation of an original project that was called the Ecological Marine Units, that was commissioned by the Group on Earth Observations to provide a global ecological characterization of the world's oceans. And the Group on Earth Observations commissioned global ecological marine units, which is that's a chapter in volume 1 of GIS for Science. But the next step in this was to extend this to coastal areas, particularly to characterize coastal zones in terms of their ecology and to have a systematic way of doing this within GIS. And as we're seeing here in this part of the story, the idea is to be able to capture areas where biodiversity is threatened. So this is one of the case studies in terms of islands as epicenters for species extinctions that this particular work will be useful for. And in terms of birds that are in danger, fisheries, coastal fisheries, the idea of global conservation of islands, islands as small developing nations that are actually leading the way in terms of showing us how best to preserve our coastal areas. And this work is also tied to a database of island invasive species eradications that is one of the partners of this group that Roger Sayer of the USGS is leading. This includes researchers at the University of Auckland, the IUCN, and many others. And so this chapter, the way that it was laid out in terms of the beautiful photography, the beautiful maps of antiquity and of modernity, along with, as Christian was saying, the text that tells you the story of this particular project, we think is a very nice example of a very powerful scientific story. So this leads into our next chapter, Unlocking Ocean Intelligence, which is about another very large collaborative effort. This time it was led by NOAA, and specifically Lisa Wycliffe and her colleagues within NOAA Fisheries. And the idea here was to, in fact, NOAA worked with the Bureau of Ocean Energy Management to put together a system of reporting that will help researchers, but more importantly, those who are actually managing the ocean's resources and planning the ocean, not land use planning, but ocean planning. And the idea is to be able to plan the different human uses of the ocean from its surface, sea surface, all the way down to the sea floor. And this can be for energy production, for marine transportation of goods and services like shipping, even for military readiness, certainly for conservation in terms of offshore marine protected areas, and,
Aquaculture.
and aquaculture as well as another big one. So this chapter is about Ocean Reports, which is their automated ocean planning analysis system. And Ocean Reports also draws upon the Ecological Marine Unit's Digital Ocean that we talked about earlier. That was one of the precursors for the prior chapter. So,
Let me talk a little bit about this. One of the really neat things for me, because I'm not a scientist or even a trained geographer, my background is really in publishing and editing. But in working on this book and like this chapter in particular, it really gave me an opportunity to kind of take a deep dive into something that a lot of people don't really think about. It's like all this information about the ocean is being really rapidly collected right now. And this Ocean Reports project is a very ambitious project to bring all that information into a common platform, which is a GIS platform delivered online. And so when we're building the book, when we started, we thought we wanted to build something that was kind of a hybrid between Wired magazine and National Geographic from a visual sense, and also Scientific American, and kind of bringing those three concepts of publishing together into one place so that the book could be interesting to a lay audience of people who are just generally interested in the world, and like I said earlier, and how um, geography and geographic science are brought to bear on these problems.
So, with that in mind, you see how the visuals fill up the pages in these chapters, which is very, very appealing, and something that we wish that more scientists would be able to do within the pages of scientific journals. But this,
And I think this might be a good point also to mention that we have a companion website for this book and the first volume, and that can be accessed at gisforscience.com. And if you go into that website and you click on the chapter heading for this particular chapter, you'll find a lot of digital resources that allow you to actually go in and explore this data from a more hands-on standpoint.
so here is GISforscience.com, the supplementary site. Christian, did you want to say a few more words about this?
Well, what this is a collection of digital resources organized by chapter that were compiled by the authors of the book. One thing that's kind of funny about publishing books about technology is that, here we are, we're describing all this great interactivity, and these are not static maps in many cases. They're interactive maps that you can drill into and pull up additional information on. So it's really not enough just to strictly talk about it in a book. So in this particular case, we have the individual chapters. If you click on that one, the Unlocking Ocean Intelligence. See if we can get in here. And which one is it? About the Ocean Reports tool, various digital resources connected to that. And there's the Ocean Reports tool down on the second row.
The actual tool.
Yeah.
Mm-hmm.
Yeah.
Part of the supplements is the videos that show you how to get started using this tool. But in this case, I'm just starting in terms of drawing a specific area that I'm interested in to get started, and then it will allow me to draw reports from this particular area in terms of how big it is, what the depth and elevation of that area is, what populated places are part of this, what are the federal, state, and county jurisdictions, what is the protection within in this particular area, and so forth. And then you can draw upon a whole series of additional information about this particular area that I've just drawn on this map. So that's how the tool starts off working.
Mm-hmm.
Anyway, I'm back to the supplementary site. So for this particular supplementary site, there are videos, there are technical reports, there are journal articles, as well as the actual tool that was the subject of this chapter.
This is the real payload of the chapter, to tell you the truth, from an educational standpoint, because you can read the chapter in a half an hour or less, and you can go in and spend hours exploring these resources on any of these chapters.
And the GISforscience.com site is free, it's open, so you could actually go to any of these supplements without reading the chapters. But the idea is to read the chapter first and then go to the supplementary information that is present. So the next chapter that we were going to talk about is the geography of ocean plastics. So we'll go a little backwards here and show you some of the supplementary information for that chapter, which includes story maps, as well as a couple of meeting posters and journal articles. But this chapter is a little different because it also includes a GitHub repo of computer code. Go ahead, Christian.
I was just going to say this is a chapter about modeling of the ocean surface and how plastic debris moves around. We've all heard about the great Pacific garbage patch or the Pacific gyre. Well, this chapter attempts to actually model the surface movement of water and how those plastics are carried all around the oceans, and also gets into the source of the plastics coming out from major rivers. I think there are 12 rivers projected.
Yeah, so now we're back to the actual chapter in the book.
Right. So we open this chapter with not a very pretty picture of a beach in Africa, Ghana. And, I don't think anybody has any doubt about the severity of the ocean's plastics problems. I think somewhere in the book we mentioned the statistic that 99% of all plastics ever manufactured in human history are still in existence. They don't biodegrade. It's a huge problem. We have this issue of the what's been called the Great Pacific Garbage Patch or the Pacific Gyre. And what this chapter does is it shows how to use GIS to actually model the sources and the movement of plastics in an attempt to eventually curb them at the source. So this diagram kind of shows two of the main convergence zones where the garbage patches are found. This is a big data problem, and this is a kind of a machine learning, artificial intelligence problem that's solved or beginning to be solved from a modeling standpoint with ArcGIS Pro. Go ahead, Don.
And this is very useful from the standpoint of not only the approach and the workflow in GIS to model the journey of plastic through the ocean, but also to talk about the actual computer code. So, as Christian mentioned, this is actually a machine learning chapter, and it uses algorithms from R, the R Spatial Statistical Package, and also showcases how R and ArcGIS can be used together for this particular application. So the authors do the modeling in R, and then they give us the map of hotspots of plastic pollution using our hotspot algorithm in ArcGIS. So this chapter is a bit more intense in terms of its scientific content, the spatial statistics that's involved. So it's for a more advanced audience, but it's talking about a problem that we are all concerned about and all want to do something about and all want to know about how we can monitor it in the future as we change our personal behavior to stop putting plastic into our water systems, into our oceans, stop using plastic altogether. But in the meantime, as Christian mentioned, we've got this big problem that already exists in the ocean. And this is how you can model interactions between plastic and between the life that it's harming. So again, going back to the supplementary section of the book, that section does actually include the R code in GitHub that was used in the chapter.
And it's actually quite easy to implement, even if you don't really understand, what you're looking at. The actual mechanics of dropping this code that you would download into an ArcGIS Pro project is just about the simplest thing you could do. So we've really made some breakthroughs in the technology of integrating advanced kind of spatial modeling and R and statistical packages in the ArcGIS Pro environment.
Now, I know we're getting a little bit of short on time now, but we've talked about basically how the Earth works in terms of the first study, in terms of the mapping the global islands, how we interact or how we're changing the Earth in terms of the plastic pollution that we're putting into the ocean. But a third part of how we interact with the Earth in terms of science is how we look at the Earth. And so here I wanted to focus on the monitoring disasters chapter. This was another great example of a collaboration with a federal agency, Jeremy Kirkendall and Garrett Lane of the NASA Disasters Program. And here again, the layout of this chapter is pretty stunning in terms of understanding how NASA Earth science works with all the various satellites and the sensors that are on the in space to monitor our planet from space, and focusing on the mission of the NASA Earth Science Disaster Program, which provides a mapping portal to satellite imagery of fires, such as the Australian bushfires, floods, hurricanes, and many others. So this is a pretty terrific image that we got from NASA that's in the book. Christian, would you like to talk about?
Sure. So, I think all of us are aware that there's just a huge number of satellites orbiting the Earth and capturing all kinds of data, natural light data and multispectral data and temperature data and elevation data and all kinds of things. And it's being collected 24/7, all year round, capturing all these different events and processes that are happening on Earth. It's just an overwhelming amount of data for anybody to get their head around. And what I really love about this chapter and the work that Jeremy and his team have done at NASA is they're attempting to become kind of a clearinghouse of satellite imagery that's collected by NASA and actually other agencies too. I think they get into some of the European Space Agency data and coordinating with that. But it's just really, if you go to their website, we don't have time to show it in this talk, but it's linked in the GIS for Science companion website. And you can get on there and start to kind of systematically explore data from all the different sensors that are up there. Even if you never plan to actually use the data in your own work or your own research, it's just a fascinating glimpse into kind of man's ingenuity. The fact that we've been able to get all these sensors up in space and collect the data and synthesize it and organize it and make it actually very easy to use for GIS and geography people, just to download it onto their computer and look at it, or download it and analyze it in ArcGIS Pro or ArcGIS Online. So it's a very impressive attempt, I think, to really begin cataloging all of this data that's out there. And the internet has just created amazing opportunities for people to get their hands on this data. It's really exciting, and I don't think people really realize how much data is out there, just like literally a click away.
Yes, really agree. And what the NASA Earth Science Disasters Program is doing is making use of the processing and even analysis of these huge data sets in the cloud as well. So you can do quite a bit of this now, even within your web browser.
Right.
So within this particular chapter, they talk, for instance, about measuring rainfall throughout North America and South America, predicting landslides through a landslide susceptibility model that can actually live in the cloud and calculate on the imagery that's in the cloud and return the result within their portal, within the various maps there. But also, if you do have the capacity to download the data, this is a workflow, a GIS workflow, that shows you how you would go about modeling the susceptibility of a region to landslides, given the 30-minute precipitation data from satellites and other types of data layers. And they have actually calculated landslide susceptibility globally in this example here. But again, the way that this is laid out is pretty stunning in terms of the large format maps.
Yeah, you just passed the fire examples. I mean, that's just a great example out here in California. Of course, we've had a terrible fire season still going. Actually, the fire's burning very close to us right now. There are ways very easily to get into ArcGIS Online and load a fire perimeter map and what's called a VIRS, VIRS. You could probably explain what the acronym stands for, Don, but it's actually a real-time heat map. So it's quite amazing to think that you can get on to your computer and just in a few clicks, you're actually looking at very near real-time imagery of fire incidents all around the world.
And we don't have the specifics in this particular chapter, but there are other colleagues that we're working with who are modeling the impact of these fires, these coastal fires out on the ocean in terms of the not only the air quality, but the soot, the pollution that is generated by these fires settling into the upper layers of the ocean and affecting the food chain, the ecological processes in the surface part of the ocean as well. So, and this was a great example of how NASA actually collaborated with government agencies in Australia to create the first plume model in GIS of data coming from the Australian bush fires.
Right.
So one last feature of the book that we wanted to share with you is the final section of the book, which we call the Technology Showcase. And the Technology Showcase is, we think, a wonderful way to show how Esri developers, product engineers, specialists. We have many Esri staff who are scientific experts in various areas, and they have come together to create innovations that are actually serving the needs of scientists as well. So this technology showcase is actually in a flip book as well that you can get online, and the link to this flip book is in the supplementary site that we talked about before. But in this technology showcase, for instance, starting off with the Spielhaus map that we talked about before, this is a two-page vignette by the projection geometry team that actually created the Spielhaus coordinated projected system in ArcGIS and made this innovation available to scientists such as the JCOM scientists who requested it, as well as the cartographers, including the great John Nelson, who has come up with the color schemes and other ways that you can display this map in ArcGIS Pro.
I love this map. You know, I've showed this to a lot of people, and I don't think a lot of people realize that all the water in the world's oceans are connected. It's actually, they call it Earth, planet Earth, but it's really planet Aqua. You know, there's more water than land on this place. So it's just a beautiful depiction of it. And I think it really hits home to see it like this.
Yes, so true. And I think it's this way of looking at the planet that we need now, especially as we're trying to focus on how important the ocean is for life, no matter where we live, and also how much in crisis the ocean is on this planet Aqua, this planet ocean. Another technology showcase I'm going to flip through here was work done by our spatial statistics team to look at the patterns of the harmful algal blooms off the coast of Florida, also known as the red tides. And they have had some significant red tide events recently that have really hammered their coastal economy. So this particular vignette talks about ways that you can model that and map that in ArcGIS Pro. We have a new spatial temporal series of toolboxes of tools that help you to do that. So it's a real contribution to spatial statistics, but also to the marine ecology and fisheries communities to help them to get a better handle on what's happening given the good spatial temporal data that they might have.
So I think we're out of time now. I want to thank you for giving us the opportunity to present some information about this book. I will let you know that the book will be available in hard copy and in ebook format beginning on December 1st. And also, if you go to the geography2050.org website, there will be a link there to sign up for a free copy of the book. We're going to be giving away 15 copies of the hard copy book as soon as it's available. Thank you.